Hello, Maurieo! In this video I'm going to take a set of field notes, reduce them and put them into a Travis sheet and close the Travis. Okay, so let's set the scene. You are given a Travis a colleague has been done. So we have some raw field notes in a diagram below, which we'll get to in a minute. The Travis started by checking old survey marks and then putting in new survey Travis marks. Old iron tube 1 has coordinates as shown, and old iron tube 4 similarly has these coordinates. What we need to do is to fully reduce and complete the field notes and adjust out any bearing misclose. Then take the final bearings, rounded to the nearest 10 seconds, and the distances rounded to the nearest centimetre or 0.01 of a metre, and complete the blank Travis sheet, starting with the origin of bearings, Travis, line, and then coordinating the new Travis marks. We'll then have to adjust out any misclose by the Bowditch method to determine the final coordinates for the Travis. We will then show the misclose as a representative fraction and determine the final misclose bearing and distance. Once this is done, we will complete a diagram of Travises by writing in the final bearings and distances between all the marks. Here we have the diagram from the field book. We can see old iron tube 2 here, which we have coordinates for, and old iron tube 4 here. Old iron tube 1 situated here. It appears that we have lined in iron tube 4 between old iron tube 1 and old iron tube 4. And then from iron tube 1 we have Travis to iron spike 1, onto iron tube 2, onto iron spike 3, and then back onto iron tube 4, which we lined in. Okay, well, here we have the field notes, just the view of the whole thing is a single page. I really recommend that you have a copy of the field notes in front of you, perhaps a copy of the plan and what have you when you're going through this video, because it would be more than helpful. Copies of the notes are available from me, maurieo at maurieo.com. So just send me an email and I quite happily flick out a copy of the notes that go with this video. Just looking at this, we can see we start at old iron tube 1, which is the starting point with our origin, move on to iron spike 1, iron tube 2, iron spike 3, iron tube 4. Okay, so let's zoom in and just get on with the business of reducing these field notes. So, okay, and we'll start at iron spike 1. Okay, and here we are at iron tube 1. So generally the first thing we do is to reduce or mean our left and right face. So I'm just going to go over to my hopefully my answer sheet here. Alright, so let's just mean the left and right faces at iron tube 1. There we go. Now we always have the first bearings, usually in most cases, the one we orientate on. So in this case here we're orientating on our bearing from old iron tube 1 to old iron tube 4. So that's going to require a small, what we call an orientation correction there of 20 seconds. Now that applies to all of the bearings in the round so that they're all in terms of the same origin. Okay, so let's have a look at what we've got there. Now the first thing that we know is that iron tube 4 is online, so it should have the same bearing as that there. So we'll just put that in there, and that's going to require, it would appear, a small correction of 5 seconds, which is pretty good under the circumstances. And we also know the bearing from old iron tube 1 to old iron tube 2. That's our check origin. So we can see there that we're, just a small 10-second correction there, which is pretty good, pretty fine, is not a problem. So here we have our bearing forward bearing to iron spike 1. So we're going to go to iron spike 1 and we will use a bearing 180 degrees different to that as our back bearing. Once again, of course, we mean our left and right face, apply our orientation correction to bring everything in terms of our back bearing, and then calculate our forward bearing. So this is again what we do at our next station, iron tube 2. Again, 180 degrees different. Next thing to do is to mean them, like so. Determine our orientation correction and work out our forward bearing. So there we go. We're off to iron spike 3, where we're going to look back there at 308.32.40, which we mean, and apply a orientation correction there of 25 seconds. So we can do all of that at iron tube 4 there, and carry our 165.26.55 bearing forward. So we'll just that's our forward bearing there, and there we go. And we can, oops, okay, so let's do our means and apply our orientation correction to our observations here. I'm just copying them from another sheet, and where I have the answer, so there's no calculation going on. Right, now we can let's have a look at here at iron tube 4. We know what our bearing to old iron tube 4 should be, so we just of course it should be that, and so then we can work out what our bearing misclose is, which is 45 seconds. That's 45 seconds over 5 stations, which works out at roughly 9 seconds per station. But before we go, we can just deal with this one here, because it's online. It should be the same, so just 180 degrees different. So we start to apply our 9 seconds. Now it's 9 seconds per station. We're going to be working backwards from 45, so if we make that 30 seconds, that's got rid of accounted for one lot of 9 seconds, which we just adjust like so. So it's usual then to just work back the way we came. So here we go. That's that one with our 36, and then in here, of course, 27, and got rid of it, got sorted out another 9 seconds, and we just work backwards through our series of stations and what have you, so that we can. So this one here will be obviously 18, and it's plus 18. Apply that there, and this one here again is 18 will apply, and here of course will be 9, and then we get back to where we started from, and we apply our 9, and obviously 0 there. So there we are, we've distributed 9 seconds per station. And now the next thing that we want to do is to just show our final bearings all nicely rounded and what have you. So we do that here like so, rounded to the nearest 10 seconds, make them red, make them bold. Okay, and similarly here, and we'll make them red, make them bold. Make them red, make them bold. Okay, and do the same here. Make them red, make them bold. So that's our bearings have been reduced, misclosed there, and rounded, and they're ready to be shown on our diagram. Now the next thing we need to do is to reduce our distances to the horizontal. So here we have our slope distance here and our left face zenith angle and our right face. So what we need to do there, of course, is to, we need to do that with all of them, is we add them all up. Add them all up to 360. This one here exceeds 360 by 20, so that means we have to take 10 seconds off the left face, 10 seconds off the right face, and we just show the right face one there, 92, 30, 30. So now we need to calculate our horizontal distance. So what we do to do that is we get a call on our little calculator here, and quite simply I'll just on our calculator there, yeah, we've got it in there. So it's fairly simply 92 point, oh, we're in grads there, so let's just make sure that we've got that in degrees, because we work in degrees here. There we go. So 92.3030. Let's convert that to hours, take the sine of it, and then we multiply that by our slope distance, 256.668 times, and 256422. Let's just see how we go. Yep, there we go, got it right. Okay, and then these here will be, we want to round those to the nearest centimetre, or 10.2, and make them red, make them bold, and that's how we do it. So yeah, just the sine of the zenith distance times the slope distance there, and there, that's that set all ready to go. We can do the same here. Yep, that's all good. We'll just copy these ones here into, oh, we're going to do a bit more than that, don't we? So we'll just copy all those into there. Done. Control C. Put those ones in there. Oops, didn't want to do that one. Okay, so that's them all done, and just same process each time. Just as I say, yep, add them up, apply the correction, and there you go. So that's our field notes there are now all fully reduced and rounded and what have you, and that there could possibly go up to 3 decimal places really. And yeah, so now the next thing is that we're going to add all that information to our plan, and then complete our Travis sheet. Okay, so here we have our plan, and on that we have recorded all our rounded bearings and distances all ready, and we've checked them out, checked that our totals sort of all check out and what have you, or from what we know, and we're going to use our Travis sheet now to prove that. So let's so this is the equivalent of our diagram in the field notes, where once we've reduced our field notes, we write all our reduced and rounded bearings and distances onto the diagram in the field note, and from there produce our Travis sheet. From our Travis sheet, produce our plan. And voila, here we have our Travis sheet with all our bearings and distances recorded from our field notes and diagram or plan. The first thing we're going to do is to close out between old iron tube 1 and iron tube 4. We have the known coordinates for these. Old iron tube 1 and old iron tube 4 are in at the start up there. So we're just going to close between them. So we put our bearings and distances in, and we see that our misclose is actually 0, 0. We're pretty good there. So there's going to be no need for any adjustment, and we can work out our total coordinates straight away. Summing up our distances, 256.42, with no misclose, we can work out our representative fraction is 1 to infinity. So that's pretty good start. So then, using our coordinate for iron tube 4 and old iron tube 1, we're going to start at old iron tube 1 because that's where we start, and finish on old iron tube 4. So we've just used the coordinate here from iron tube 4, and we're going to close onto that here. And here's our coordinate from iron tube 1, and we're going to go through iron spike 1, iron tube 2, iron spike 3, and back to iron tube 4. So we put in our bearings and distances as we've calculated them in our field notes, and these are our distances. These are to the nearest 10 seconds, these are the nearest centimetre, and then we do our running out, or work out the ordinates or components of each of these vectors, and record them accordingly here. Alright, and when we add those up and correlate them with the final coordinates here, we find that we get a misclose of 0.2 and negative 0.4 accordingly here. So these are adjustments that we need to make. So when we look at our raw coordinates, we would get 5860.52 presumably. So we must distribute our misclose using the Bowditch adjustment. Now our misclose here is relatively small. I would sort of, the Travis lines are quite even, so I would distribute my misclose in this instance just by inspection, and just sort of, as I've shown it there. We could use a precise Bowditch adjustment where we would multiply the misclose 0.02 times the distance divided by the total distance here, which would give us a small adjustment to each one. But as we can only really deal with 0.01s, this is the way I've done it here. And similarly with the 04s, I've just done 1 per vector there. We can then, using our misclose here, we can calculate the bearing and distance of the misclose and the total distance there. So we divide 184.24 by 0.04, which will give us a representative fraction of 1 to 4,606, which most survey software, in New Zealand anyway, calculates out for you. So, and then it's just a matter of working out your total coordinates, taking this value here, adding the northing, adding the adjustment to get this one here. And similarly, as we work through, making sure, of course, that we do actually end up on the end value, and closing it all out. And there you are. There's your Travis sheet all nicely done and presented there, and that's all we do. So that's my this is maurieo, and this has been my Travis closure.